switching characteristics. Switching characteristics, first I want to explain. You can see this picture. So this is a park. This park, how do they will going to, what they are doing? Okay, so you in that one see the picture and explain. So see there, so these two members, there I think one family members, okay, father, mother and one child, they are going to talking. So that is there. There are two kids, they are playing on the ball. Okay, one lady, she's start to painting. Okay, he's one of the person. He's jumping. So sorry, jogging on that one. So he's doing on that work. Okay, so one of grandfather is there, and with one of the kids. Okay, kid, it is they are talking, interacting. Okay, so see the pictures and start to explain. So this is a similar, you can say, about the dynamic characteristics. In the dynamic characteristics, see the picture and then you can say. For example, first step number 1, what is on time? Step number 1, on time is equal to delay time plus rise time. This is a point number 1. Delay time plus rise time. Next one, question number 2, what is the delay time? So during the delay time period, ID is the output current is a 0. During the delay time period, output current is 0, but input voltage is start to rise from 0 to the VGST, T for threshold, reached the threshold. Then next one, step number 3, next one is a rise time. During the rise time period, input voltage is start to rise from threshold value to the peak value. It is a rise from the threshold value to the peak value. Yes, it is a rise. Okay, it is a rise. Okay, then what about output current? Output current is a rise from that 0 to that saturate level, 0 to the saturate level or a peak value. So this is about the on time. These things is how it is happen. These things how it is happen means this is a first step. So you will going to give the pulse to the gate terminal. You will going to give the pulse to the gate terminal. So it is include for delay time, then rise time. It is a happen. So this is a method for that. Once you will going to give the pulse to the gate voltage. So gate is terminal. Once you are going to give the pulse. Okay, you are going to give the pulse. Next one. Okay, off time. So off time is now you can see. Now I will going to say this one off time. I will going to remove the pulse. I will going to remove the source. Okay, how I will going to remove this a pulse is given. This line I have removed. Okay, I will going to connect it to the ground. If I will going to connect it to the ground, remove the source means it's a controlled turn off. So it's a controlled turn off or controlled turn off, you can say. So during that one you have see I have removed the pulse. Okay, now it is start to discharge. Okay, pulse is removed. Then what happened? Turn off is take place. The turn off. Okay. Yeah. The turn off also it is included. What are the two things? One is a delay and then fall. Okay, delay plus fall. Okay, delayed. Okay, DF. And the other one is what is that one? Yes, DF plus TF. DF plus TF. So what is the DF? Okay, delay fall. Delayed time to fall time. Delayed time to fall time. What is that one? So it's a combined. First step number 1, it is a turn off. It is equal to TDF plus TF. Delay turn off. Okay, plus TF fall time. Okay, what about the delay? Okay, delay. Delay fall. What about that one? So it is a start to move from the peak value. Okay, peak value. Okay, peak value to that one. I mean top value into the peak value. It start to move from the V1 to the VGSP. Okay, top value of that one, full value of that input voltage to that VGSP. So VGSP, it is moved from that top of the value into that peak value. So during the terminal, what about that output current? Output current is maintained the same value. Output current is maintained same. Then fall time period. Fall time is nothing but it's a peak value to you will going to reach into the threshold. Peak value to the threshold. So during that one, the voltage is slowly it is that one move from that peak value of that one into the threshold value. So voltage is reduced. Y-axis is a voltage. So voltage is a reduce. Okay, during the input voltage is reduced means what about output current? Output current also start to decrease. That's all. Output current is start to decrease. Totally it is reached to the 0. That's all. So once output current is 0, it is a turn off. So that's all. So the once again I will going to repeat, turn off is nothing but a TD. Okay, this you will going to give the name. Okay, delayed time. Okay, delayed time. Okay, F simple to say. Differentiate purpose TDF. What is it? The differentiate means delay time you have used it for that turn on. So here is a same, but it is a fault. Okay, turn off purpose you are using. That's why I will going to give the differentiation F. Okay, plus fall time, plus fall time. So this is a step number one. It's a okay, TF is equal to TDF plus TF. What is a TDF? TDF is nothing but okay, it's a peak value of the input voltage, peak value to sorry, what is that? Sorry, this is the highest value. You can say this highest value V1 to peak value, highest value into the peak value. It's a start to decrease. So during the time output current is maintained as the same. The next one, TF. TF is nothing but a fall time. During the fall time period, what happened? So input voltage start to decrease from that peak value to the threshold value. It start to decrease. So during the time, what about the output current? It is start to decrease. So totally it is the highest value to the zero value reached. That's all. That's the turn off.